Hello and welcome to the presentation of Sustainable City Clusters, a project on sustainability and digital transformation. My name is Edgar Valdez and I'm a physicist and a consultant on technology. As a physicist, I am interested in mathematical models inspired by physical intuition, and as a technology consultant, my field of expertise is on analytical business software. The goal of this talk is to present sustainable generated networks fed by big data. First, we are going to present some facts and figures about the importance of data. Next, we will give different perspectives on big data, followed by a definition on sustainability and its impacts. This will lead us to the understanding of data transformation as a complex phenomenon. Afterwards, we will generate sustainable networks and its transformations applied to the study of urban centers. The concepts presented in this point turn out to be naturally plugged into the current technological landscape. Finally, we will assert some conclusions. To understand the importance of big data, we need to see how it is generated. In 2020, we expect 4 billion of people connected all over the world, using more than 25 billion embedded systems with at least 25 plus million apps created. All of this adds to a 4 trillion of revenue opportunity, which in turn will generate 50 trillion gigabytes of data. We are now mainly interested on what we can tell from data. This can be done by turning invisible information into visible by analysis and visualization of big data. The amount of data nowadays generated induces us to make the question: how can we use big data to understand and improve sustainability? We begin our discussion by talking about big data. Big data has become an important topic among all levels of society, therefore revealing a diversity of perspectives on what big data is. First, as a product, it is described by data attributes like size, transmission velocity, and structure complexity. As a process, it relates to all activities of storage, access, modification, and analysis of vast amounts of information. From the cognitive perspective, big data is seen as a tool for amplifying human capacities related to the understanding of complex phenomena. The discussion of big data is not dilemma-free, but its importance is no doubted. Now, let's change to the concept of sustainability, which has many different definition approaches. The more common definition comes from the Brundtland Report, stating that sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own. Despite the discussion on its definition, sustainable development is a global goal that has a deep impact on all human activities. Moreover, since 2014, the United Nations has established 17 global goals towards transforming our world by 2030. Sustainable development goals such as good health and well-being, decent work and economic growth, and gender equality affect millions of people. All of these are complex problems that require technology solution such as big data, supercomputing, cloud services, and hyperconnectivity. The same occurs from the goals of sustainable cities and communities, climate action and responsible consumption, and production. We can see that the effect of technology on sustainable studies is an active operational and research topic. But we must keep in mind that technological tools aid in the solution of these problems. Further actions are required at the social and political levels to achieve a definitive solution. Complex phenomena appears when many interactive components perform non-linear activity. In a way, big data must be related to complex phenomena. Let's think about a simplified model which, on one side, has structured or not structured data, and on the other, connected information. We set on this model a transformation from the former to the latter. At technological level, OLTP encompasses the gather, read, or change of data, while OLAP tools are more related to analytical process. Common business intelligence task covers the identification of relations and the analysis of them at multidimensional levels. Now, if we take into account big data as a source, automatization is of course required. As an example, machine learning algorithms could be used at the analytical level or at the search level. Our main proposal is that sustainability scope must be added at transformation level. On this project, we select sustainability development of human settlements, since the magnitude of its effect on energy consumption. We focus particularly in urban centers. To study sustainability in cities, we require to measure a general characteristic and select the significant attributes that describes it. For example, we may be interested in livability, lifestyle, safety, or sustainability in a broad scope. For the purpose of this talk, we will concentrate on Arcadis Sustainable Index and its categories on social, environmental, and economical sustainability. Based on the Arcadis 20 indexes, modelation starts by setting all indexes as nodes, then relationships among them are defined, and finally, natural index classification is translated to the nodes. Related and categorized nodes becomes directed networks, one for each category of social, environmental, and economical sustainability. The information on these networks is translated to a sustainable diagram. Radius on this diagram are associated with the indexes measured on each category, while angles between them are related to the weighted values of the directed networks. This, in turn, give us a complete relationship among the original indexes. The process is repeated for every city, and gathering all sustainable diagrams, its elements can be identified with points on a differential manifold, which we call a cluster diagram. The purpose of this diagram is to represent the sustainability relationship among cities, and moreover, optimization algorithms can be applied directly over a second set of networks shaped by the points of the cluster diagram and a suitable metric. These are called clustered networks. Having the cluster diagrams, we can perform different activities. One of these is mappings, which completes directed networks by joining previously isolated elements using the properties of the cluster diagram. Also, they can be stored on a columnar in-memory database. The final product is a complete related network that can be used by different networks algorithms. A vast amount of directed networks can be integrated by studying the transformation over time for a cluster diagram. This could lead us to different instances of a database and encapsulate a sense of dynamics. Also, we can think about some kind of evolution. This can be done by using optimization over the cluster networks, in which we can enhance some of the sustainable characteristics guided by the achievement of a resilient state, which is also a particular cluster diagram. We have demonstrated that we can create networks using differential manifolds, but also it is important to link it to technology. Now on, we are beginning to understand that technological trends such as digitalization, hyperconnectivity, supercomputing, cloud services, and big data come hand to hand with global trends such as population growth, demographic change, urbanizations, resource scarcity, and climate action. From the big data trend, mature solutions are now available at the market, and these solutions forming what we call a technological landscape. In order for this landscape to be useful for our algorithms, they must have services at the database, application, processing, or integration and quality scope. We imagine that analytical services on graphs or network as key enablers for global inclusive business and as a catalyzer for the economic development. We now conclude. First, we propose that the use of cluster diagrams and sustainable diagrams as tools to understand sustainability. This could lead us to use them as key enablers towards digital transformation. Thank you, and see you next time.